Our galaxy was once thought to be its own universe, alone in the cosmos and unique in its existence. Yet through the discoveries over the centuries, we have realized that this belief is far from the case. As it turns out, there are 100 to 200 billion galaxies in our universe, all sharing some similarities. But why is this? And where did these galaxies come from?
There are two theories that explain how the first galaxies of the universe formed. In this video, we will focus on the more dominant theory, the bottom-up or hierarchical model. After the Big Bang, during a period called inflation, quantum fluctuations in the density of matter were rapidly stretched, causing the slightly denser regions to gravitationally attract even more matter, and the large-scale structure of the universe began to form. Hydrogen and helium atoms were formed through the process of recombination, wherein electrons joined with atoms as the universe cooled. As the universe expanded, some of these hydrogen and helium atoms, as well as a lot of dark matter, started to break away. As these atoms collided with each other, they produced infrared light and began to lose energy. This lack of energy caused the matter to collapse due to its own gravity, forming protogalaxies, each with a core and a halo. This caused the matter to fall to the core of the galaxy because of the gravitational pull. Because dark matter did not experience these collisions, it remained where it was in the halo of the galaxy, providing the gravity needed to hold the galaxy together. These protogalaxies are so old and so far away that none have been found yet.
As the gas further lost energy due to its collisions, the protogalaxies became denser. These protogalaxies began to attract other protogalaxies and merge with each other to gradually form a larger galaxy. Large gaseous clouds began to form and orbit the galaxy, and when two of these gaseous clouds merged, a high-density shock front formed from the cloud's compressed gas. Star clusters formed in the shock front, and the energy from the stars forced the rest of the gas in the cloud to dissipate. These stars produced the first photons through thermonuclear fusion, making the protogalaxy a primeval galaxy. Interestingly, the areas where these stars formed are remarkably similar to the star-forming regions in modern galaxies. The earliest stars died quite quickly, exploding into supernovae, similar to how gigantic stars today die. These explosions produced all the elements on the periodic table heavier than iron. These elements were forced into a shell orbiting near the edge of the galaxy. Therefore, the older a galaxy is, the more stars exploded, and the more heavy elements it has in its gaseous clouds. These elements would later go on to create planets, moons, and all kinds of celestial objects in the cosmos.
We know what the universe looks like now, and we have a solid understanding of how it began, but we don't know much about how what we see today came to be. However, Illustris, a computer simulation, helps us learn great amounts about how galaxies like our Milky Way came about. These simulations model three-dimensional space and are used primarily to study the growth of the structure of the universe. Illustris models a volume of space 350 million light-years across, which is big enough to represent the whole universe, but small enough to go into great detail, for example, being able to view individual galaxies. This simulation begins 12 million years after the Big Bang. Dark matter is represented by a web, and the dense, clumpy regions of dark matter are where baryonic matter is gravitationally drawn, and where galaxies begin to form. As time progresses, the tightly woven web of dark matter loosens, and a looser web of galaxy clusters dominates. The simulation contains 40,000 galaxies with a great variety of types that match very well what we see today, thereby giving us great confidence in the accuracy of the simulation. Where the simulation fails to represent physical reality pushes us to ask what we haven't accounted for, or what we are missing from our understanding of the physical universe.
Galaxies evolve over billions of years by interacting with one another. When galaxies are within close enough proximity, they begin to warp and interact with each other. One example is a flyby. This is when two galaxies come close enough to cause alterations to their own morphologies. This can include star formation and large masses being formed far from the main galaxy center. New characteristics can appear, like ball formations or long tidal tails. Also, galaxies can merge and absorb one another. If a large galaxy absorbs a smaller one, it is able to retain its normal shape. However, when two galaxies of similar size merge, they evolve from a spiral galaxy to an elliptical galaxy. This process is currently happening between our own Milky Way galaxy and our neighbor, the Andromeda Galaxy. When two merge, it is the gas and dust that interact gravitationally, warping the galaxy and creating new stars. The stars themselves do not interact with each other because the distance between stars is so great. A star can be knocked out of its normal orbit and sent sailing through space.